Okay, so this is section 2 of the proof and mathematical communication chapter, which is inequality notation. So we've already looked at different types of mathematical communication like consequence and equivalence. Now we're looking at inequality notation. And again, it's just trying to get you really familiar with writing things formally in mathematics and using different types of notation. So without further ado, let's crack on. So inequality notation, what is the crack? What is it all about? There are three types that you need to be aware of, okay, which are these three down here, which are inequality notation, set notation, and interval notation. Right, so if we're given something like this number line down here, you can represent the values this is showing using three types of notation. The first one, which is inequality notation, you'll be familiar with from GCSE. So this set of values here can be read as your x values must be bigger than 0, but not including 0, and that is shown by the non-filled in circle, the hollow circle, but less than or equal to the number 3. So if you were concerned with the integer, the whole number values here, satisfied by this inequality, you'd be looking at the numbers 1, 2, and 3, not 0, because you go bigger than 0. If you weren't looking at the integer values and just all of the real numbers between 0 and 3, you would begin with 0.000001, for example. So maybe you're thinking, there is a bit of an issue here with inequality notation. We're not quite sure which numbers we're concerned with. And that is the use of having other types of notation. So that is inequality notation onto set notation. So this thing here, this means exactly the same thing as what I've got written down here. Okay, but it's just a different way of writing it and actually probably more detailed. So this is read such as your x values, so these x values down here, belongs to, so this epsilon Greek symbol means belongs to, and then we've got this r, which is read real numbers. A real number is just any number that you can think of, right? Unless you're doing further mathematics, just think of this as any number you can think of. A rational number like 2, a negative number like -5, and a rational number, like pi or e. It's just any number that you can think of. And then finally, we've got this colon here, which is read such that. So this is read x belongs to the real numbers such that, and then this bit here is the same thing, right? X is bigger than 0, but less than or equal to 3. But why is this better than inequality notation? Okay, we've already said that bit. The reason is, right, this is more detailed than this because it is telling us we are concerned with all of the numbers we can think of. So things like 1.237 or 2.99999. Okay, so all of those numbers between 0 and 3. The issue with inequality notation, right, are we concerned with just the integer values, so 1, 2, or 3? Are we not? We don't know. But with set notation, it is more detailed. It is telling us we're looking at all of the numbers you can possibly think of between 0, bigger than 0, and less than or equal to 3. So it's just a more detailed way of writing inequality notation. Okay, but what about interval notation? So we've got the same number line here, the same range of values. How can we represent this using interval notation? We write it like this. So the same number line, this means x belongs to, and because we're not including the number 0, with interval notation, we use a curved bracket if you don't include that number. So because you don't include the number 0, we use a curved bracket. So between, this means x belongs to between, but not including 0, and less than or equal to 3. And because you are including the number 3, we have a square bracket. So curved bracket, like we can see here, value not included, square bracket, value is included. So that is important. Okay, so in summary, this number line can be represented in three different types of notation. Inequality, which we've seen at GCSE, but then these two, set and interval, are different or new ways of writing the same thing. Okay, so it's all part of mathematical communication. In questions, you've got to be familiar with it. If you see this, don't let it freak you out. It's just another type of mathematical communication. So if you need to make a note of that, you can do. And then we'll look at three examples that we'll go through together, which is going to cover you for everything. Okay, the first one, right, I want to represent this number line here using inequality, set notation, and an interval notation. And let's begin with inequality. Hopefully this one should be quite straightforward. We're just saying that your x values must be greater than or equal to 5. And I know that it's greater than or equal to because I've got a filled in circle, which is important. Okay, on to set notation. So the way we're going to write this now is, first of all, using that kind of curly bracket. So we're saying now that x belongs to, and when you write it, read it out in your head. It makes sense and it makes it a little bit easier to comprehend. So x belongs to the real numbers, and we've got this colon such that, then it's the same thing as over there. X is greater than or equal to the number 5, and then you end your bracket over here. That's not a regular bracket. So let's do that again. So it should be a nice little peak there. There we go. Okay, so again, this is more detailed than this one because it's telling us we're looking at all of the numbers you can possibly think of bigger than or equal to 5. So things like 5.237, 6.4, whereas over here, we could just be looking at the integer values. So 5, 6, 7, 8, 9, 10, so on and so forth. Last but not least, interval notation. This is where it gets a little bit more interesting. How would you write this one? We'd write it as follows. So x and then belongs to, and then because we are including the number 5, it is going to be between 5, so we use that square bracket, and then right over here we are approaching the number infinity, so we're going bigger or equal to 5, and we're going all the way up to infinity, but you never actually reach infinity, you're just approaching it. So we write this as the infinity symbol with a curved bracket, and there we go. So quite nice, just 3 different ways of writing the same thing that you need to be familiar with. The second one, let's give it a look. Okay, so we've got your x values are bigger than, equal to 7, less than 12. Inequality notation should be quite nice. X is greater than, equal to 7, but less than 12. Okay, good. Set notation, it's very similar to this, but we've got this extra bit included. There's actually another way of writing it, which we'll get into later, but I don't want to overload you for the time being. So this is just going to be written for the time being as x belongs to the real numbers such that, oh, what have I done now? I've forgotten a pretty key bit of info, which is my curved bracket. So there we go, can't forget that. So x belongs to the real numbers such that, and then it's just this bit written in here. So x is greater than, equal to 7 and less than 12. And that is not a very good colon. Let's just make sure that's a little bit neater. Okay, sorry. There we go. And there we go. Good. And then we finish off our curved bracket. There we go. So x belongs to the real numbers such that x is greater or equal to 7 but less than 12. There we go. Interval notation. So we're going to write this one as x now belongs to, and we're going between 7 and we include the number 7, so square bracket 7, and then less than 12, so 12 with a curved bracket because we're not including the number 12. There we go. We can actually write this a little bit differently, but for the time being, I'm just going to leave it as that. I don't want to overload us. The final one, right, interesting, we've got 2 separate regions here. We've got x being less than -3, but greater or equal to than 4. So with inequality notation, we write this as either x is less than -3, or separate region, we write it as x being greater than or equal to number 4. Okay, so that one hopefully should be a recap. Using set notation, this is where things get a little bit more interesting. So this is going to be written now as the following, and it's going to be a bit cramped for room in here, so I'm going to have to write it as 2 lines, but it should be 1 line written as. Again, curly bracket, we're going to be saying that x belongs to the real values such that, and the first thing we're looking at here is x being less than -3. So again, just x being less than -3. We then close that bracket. And the way we write this is kind of using a bit of Venn diagram notation, and we use a union symbol. And maybe you're thinking union means you include everything, which you do, but I'll make that clear in a second. Just bear with it for the time being. Okay, and then we're going to be writing something similar below. So now curly bracket. So it's really hard to write these brackets on this. So curly bracket, and x being real numbers belongs to such that x is greater than or equal to the number 4, and we close that bracket. Okay, so again, this should be written as 1 line, but it's just too cramped. Why am I using this union symbol? Well, if we imagine Venn diagrams like this, okay, there we go, and there we go. The reason we can use this is, well, there are no numbers that are less than -3, and also greater than or equal to 4 in between. It's not going to work out. Okay, so even though, right, the union means you include everything within the Venn diagram, there's going to be nothing in between anyway, because we're looking at numbers less than -3 and bigger than or equal to 4. Nothing is going to intersect. Okay, so we can use this symbol here. Okay, hopefully that made a bit of sense. And then finally, we write the interval notation in a kind of similar sort of way using this union symbol. So we're going to write this as x belongs to, and then it's going to be between, okay, and over here, for this first region, it's going to be approaching negative infinity but never touching it, so a curve bracket, negative infinity, we never touch it. And then also -3, and again we don't touch it, so we use a curve bracket. And then again we're using a union, and then a separate region x belongs to, and we do include number 4, and we're going all the way this time from 4, include it up to infinity, but we don't include it infinity, so we use infinity symbol but with a curve bracket. And there we go. Okay, so perhaps quite a lot to take on there. There's a lot of new notation, but it's important we just get our heads around it. If you understand these 3 examples here, you will understand everything that you need to know for AS. Okay, so I'll definitely make a note of those 3 there. Just a quick little point, which is this. Right, the way that I write some of my set notation is different to how the AQA book writes it, but they mean the same thing. So for example, right, this number line here, x is greater than or equal to the number 3, I would write it using set notation like this. So curly bracket, x belongs to the real numbers such that x is greater than or equal to 3. The book writes it a little bit more simply, okay, but it means the same thing. These both mean the same thing, just recognizing if you see it that, okay, this is both set notation. The book writes it like this, and this is going to be read as x such that, so just this time literally not x, such that x is greater than or equal to 3. But they mean the same thing, so don't let that put you off. Similarly down here, if you were given this number line where your values are between 3 and 5, including 5, the way that I've been writing this in set notation is as follows, okay? X belongs to the real numbers such that x is bigger than 3, but less than or equal to 5. The book writes it, okay, as this, which means the same thing as this. And if we think about it, it does make sense also. The book writes it as sort of 2 separate regions saying x belongs to the real numbers such that x is bigger than 3. Okay, fine. And then this here means intersection. So Venn diagrams, this bit over here. Okay, intersection, we're looking at this part in the middle here. X belongs to x being less than or equal to the number 5. So we're looking at all of the numbers between 3 and 5, which is this part here. So they represented it in 2 separate regions with the intersection symbol. But they mean the same thing. It's just recognizing that. So don't let that put you off. But personally, I write it using this notation and this notation. Okay, last but not least, I just want to go through work example 1.5, and that is going to be it for inequality notation. So it says, write each inequality in set notation. So not inequality, not interval, but we're looking at set notation. So if you want to, give that a go. Otherwise, I will go through it now. What I would do first of all, I just like to maybe draw a number line. It just perhaps helps you visualize things a little bit more clearly. So we're going between number 1, and it's a filled in circle, and 7 like this. Okay, so this is our number line. There we go. And we're looking at some x values, okay, including 1, but less than 7. Okay, so sorry, using set notation for the first one, again, right, curly brackets, we're saying that your x values belongs to the real numbers, okay, and this is the way that I write it, which is absolutely fine. Book writes it differently, but I think this is a little bit nicer. Belongs to such that, and we just write in our inequality, x being, let's undo that, x being greater than or equal to 1, but less than 7. Okay, there we go. And that is fine. Again, you could write it as 2 separate regions. In fact, let's just do that in case that confused you. So that is absolutely correct. Or you could write it a little bit differently, like this. So you could write it as x belongs to the real numbers, okay, such that x is greater than or equal to 1, okay, because when you read this, reading x is greater than or equal to 1 means the same thing up here. We then close that bracket and we're intersecting it with the second part of it, which is x belongs to the real numbers such that now x is less than 7. So x less than 7. And these 2 things here, they mean exactly the same thing. So each one of those is correct. Personally, I like to write it as this. Okay, the second one, we've got 2 separate regions. Again, I'm going to draw a number line because I think that's a useful thing to do. And let's do it in black. There we go. So we've got x being greater than 1. So we've got number 1 over here. So we're looking at everything to the right of that, but less than -2. So if that's the number 1, okay, but less than -2, okay, here we go, -2 is going down here. Using set notation, and let's go do this in red. So this one, let's go and use our curly brackets. So x belongs to the real numbers such that, first of all, considering this region over here, okay, such that x is less than -2, okay, and it is less than, not including, because it's not a line underneath our symbol there. And we close this bracket, and then because we've got two separate regions, and we explained before, we can use a union symbol here, okay? I know, again, there is nothing in between there, but we explained that there's no values less than -2 and greater than 1, so we can just write it as this. That is fine. And your separate bracket is going to be x belongs to the real numbers such that x is greater than 1. Close the bracket. Sorry, my curly brackets aren't the best, but they come with practice, and it's not very easy on this pen pad. But that is it, okay? That is our work finished, okay? And that is it, I think. Good. Any questions or anything, you can always leave a comment in the comment section, but hopefully that was useful. Thank you.